Okay, good afternoon, class. So at this point we're looking at trig ratios. For homework we had exercise 7.11. This chapter 6. Have we finished chapter 6? Is there anything that we needed to solve, sort out of chapter 6? Thursday, okay. So 7.11. Any issues here? Yeah, right. What are the issues in exercise 7.11? Exercise 7.11. It's on page 247. Yes? So it's number 9, number 7. And 12 you said, no? 9, 7 and 11. 9, 7 and 11. Okay, let's start with number 7. We are given a sine of 180 minus y equals cos of 180 plus y. So the first thing we do is we use the reduction formula. We do that first. So 180 minus takes us to quadrant. All stations to clear one. That takes us to quadrant 2. Not so? So it's sine of y equals 180 plus. Which quadrant is that? Quadrant 3. How do you get to quadrant 3? 180 plus and cos is negative. Not so? Now we have sine of y is equal to negative cos of y. So what can we do here? We know that sine of cos is 10. So I divide both sides by cos. Can you see that? So that there becomes 10 is equal to negative 1. Now what do we ask ourselves at this point? We work out the reference angle first. Arctan of 45, 145. So the question we ask ourselves, in which quadrant we stand? Negative. Okay, so how do we get to quadrant 2? It's going to be y is equal to 180 minus 45, which is 135, plus k times 180, where k is an element of integers. For the tan graph is only one solution, not so one branch. But if you had gone with 360 minus 45 plus k times 180, you will see it's a repeated solution here. You won't be penalized, you won't get extra marks either. Okay, we leave that out. Or you could have answered it as negative 45 plus k times 180. But as we say, we don't work with positive with negative angles. Okay, as we have a positive outlook on life, so you work positive angles. Okay. Right. Yes.
When you arc-tan negative 180 on the calculator, it gives you negative 45.
Yeah. You see, that's why I said we work with positive angles. That is why when we come and we ask ourselves in which quadrant is tan negative, then we take that negative into account. Okay. You see, if the other textbook deals with the negative angles in depth, but we can overcome it by adding 360 to it. Or if the angle is over 360, we just subtract 360 from it. Okay, so we always work with the positive angles. Okay, because already many of our learners have problems with this section. So to teach him in terms of negative angles, we lose him even more. Okay, so over the years I've taught them with the negative angles first, but it's just a nightmare when we mark. It's even worse than what it is now for the trick. So what I do is I just use it with positive angles. Okay, but listen, if you go through the textbook on your own and you decide, hey, negative angles works for me, or somebody else teach you the negative angles and you feel, no, that's actually better, use it on the tomorrow. Okay. Alright. People, number 9. Number 9 we have 6 sine squared x minus cos x equals 5. What's going to happen here? You change? We have to change something. Because there is cos and sine. So we're going to change the cos. Change the cos. The sine, sorry. We change the sine to cos. Not so. So what do we have? 6 into 1 minus cos squared x minus cos x equals 5. Get rid of the brackets, so it's going to be 6 minus 6 cos squared x minus cos x is equal to 5. Did you call that sit in front? Absent. That's what I was looking for. 0 is equal to 6 cos squared x plus cos x minus 1 is equal to 0. Not so? So what is this to us now? Trinomial. Yes? Don't make a mistake. 2? Where's 2 zeros? Oh! What's wrong with you? Right, people? If you cannot see the trinomial, you can't factorize like this, you're not comfortable, you can replace cos with an x. So it's going to be 6x squared plus x minus 1 is equal to 0. If you can't factorize that using trinomial rules, use the quadratic formula. Then you go straight into the fact that cos x is equal to, or cos x is equal to. You don't have to force that trinomial, factors into this, then mess it up and lose the marks anyway. You go from a trinomial and you get the answer. Okay. So it's 3 cos x 1, 2 cos x 1, that's plus and minus. So that will be a third or negative half. Did you make a mistake here, Michael?
Yes, sir.
Where was your mistake?
Sir,
Yes? Yes, and listening?
instead of saying
Plus 1. So you couldn't factorize that, or did you get the irrational values? So because you got 1, so it's going to be 6. You got 6 negative 1 and 6 positive 1, no? And then you got 1 again. So that gave you no solution. No? Yeah. But okay. A mistake. No? We all make mistakes. Some just make more than others, but okay, that's life. And I'm sure you know what to do from your general solution. No? I don't have to carry on this. Let's go with number 11. Number 11. Sorry? Oh. Number 11. You got 5 cos squared x minus 9 sin x minus 3 is equal to 0. Right, read for me what you wrote there. 5, yes?
open bracket, 1 minus sin squared x plus bracket plus 9.
Minus 9.
Why did I say plus?
I don't know. Did you write a plus?
Yes,
Now what's wrong with you?
I don't know.
Okay, so you know where your mistake is. Anybody else want me to carry on with this? No. Okay. So that brings us to the end of exercise 7.11. Let's take it out. Clever. Page 300 and 247. Right. So we're going to look at further examples of trig equations. That's now your new heading. So at this point on page 247, they now they give you a scenario there, or a equation. Consider the equation sine of theta is equal to sine of 30 degrees. We know that sine of 30 is a half, and get sine of theta is equal to half. Okay, then what you notice is that my reference angle itself, if we look here, sine of theta was half, not so. So sine of theta is equal to half. So my reference angle here, reference theta is equal to 30 degrees, not so. Then we ask ourselves, okay, which quadrant is sine? Positive. Not so. And which sine positive? The first and second quadrant. So how do we get the first quadrant? Just the angle, not so. So theta is equal to 30 plus k times 360. Or theta is equal to 180 minus, which is 150, plus k times 360. Where k is an element of integers. You see that, people? But if you look at this here, if you got sine of theta is equal to sine of 30, what do you notice? The ratios are the same. So what I could have just done was drop the signs. If we drop the signs, it simply becomes the reference theta is equal to 30 degrees. Not so. Question you ask yourselves, in which quadrant is sine? Positive. 1 and 3. So there it goes into quadrant 1. Sorry, quadrant 2, not 3. Does that make sense, people? Then I can just drop the signs. How is that going to be of a benefit to us? It could be of a benefit to us if this was not a numerical angle. So if this was a variable angle here, then I couldn't have taken as I did here on the side. Can you see that? I could have worked out the ratio. But what if this was sine of theta equals sine of 2 theta? Could I have worked out one of the two signs? No. Then I could have just dropped the signs in this case. Does it make sense? Okay, so that is the example there. If we go further on in the textbook, the next page, it deals with exactly the same, but one dealing with cos. And then you further on, you got the sine and the cos there. Okay, but we'll speak about that now. Alright, let's look at example 1. This is on page 248. Page 248, no? Alright, here we go. Go for it. Shh. Right, write that down. Solve the following equations for alpha. Cos 3 alpha is equal to sine alpha, where alpha is greater than 90 but less than 90. So here we got the restricted domain as well. Okay. Okay, so cos of 3 alpha is equal to sine of alpha. Alright, so remember this is now the non-numerical angle. So we couldn't have worked out one of the two sines. Can you see that? However, we got cos and we have a sine. Can I drop that to those two? No. Could I have divided both sides by sine of a cos is 10? Could I divide both sides by cos of 3 alpha? Could I have done that? No, why not? The angles are not the same. So you can't do that either. Can you see that, people? So what do we say? Okay, I normally keep the first and change the second. So I say cos of 3 alpha is equal to, if I have to write the cos here, what will the angle then be?
90. I'm sorry.
Are you nuts? You see why teachers not supposed to have guns? I would have probably Okay, so it's 90 minus alpha. Okay. 90 minus alpha. So, can you see cos of 90 minus alpha is sine of alpha? Not so. Now what? Now we can drop the causes. So if I take all cos on both sides, so that gets dropped. Not so. So what do we have? Reference 3 alpha is equal to 90 minus alpha. So now at this point we don't take anything over the equal sign. We don't simplify until we posted it to its quadrants. Make sense? So the question that comes to mind is which quadrant is cos? You see there's no sign, so it's positive. You guys understand? In which quadrant is cos positive? And which quadrant is cos positive in? First and fourth quadrant. Okay? So how do we get into quadrant 1? How do we get in quadrant 1? It's just going to be the angle, so it's 3 alpha equals 90 minus alpha plus k times 360. Why k times 360? Because the cos graph period is 360. Can you see that? So from here, it's just a matter of solving for alpha. You take it over. So 3 alpha plus alpha is 4 alpha is equal to 90 plus k times 360. Divided by 4. So it's 22.5 plus k times 360 divided by 4 is 90. Okay. 4. Quadrant 4. How do you get in quadrant 4? 360 minus. So it's 3 alpha equals 360 minus that angle. So what's the angle? What's the reference angle? 90 minus alpha. Can you see that? So it's 90 minus alpha plus k times 360. So it's just a matter of simplifying. So So that's going to give you 3 alpha equals 360 minus 90 plus alpha plus k times 360. Okay? Now what? Now we solve for alpha. You take the alpha over. 3 alpha minus alpha is 2 alpha. 360 minus 90 is 270 plus k times 360. Divide by 2. So the 270 divided by 2 is 135 plus k times 180. Where k is an element of So, remember that we have a restricted domain here. So what do I do now? I say alpha is an element of, and as we did before, we substitute 0, 1, 2, and minus 1, minus, and so on, until they're exhausted on either end. Okay. So if I put 0 through here, the answer is 22.5 degrees, not so. If I put 1 in by k in the first branch, I'm going to get 2.5, which is outside the given domain. Can you see that, people? You guys following? Right. So if 1 doesn't work, 2 won't work. Okay. Now we put negative 1 in. So it's 22.5. 22.5 plus negative 1 times 90. It's going to give you negative 67.5, which is within that given domain. Negative 67.5. If I put negative 2 in, where I see k, it's going to be outside that given domain. Can you see that? So that branch is exhausted. Now we use the next one. This one. Put 0 in, I get 135. Already it's outside. Can you see that? If I put 1 in, of course it's going to give you even further away from the given domain. If I put negative 1 in, and we get an answer of negative 45. Put negative 2 in, it's going to be negative 225. So that's not going to work. So there is my 3 values. Okay, any confusion there, people? Huh? No? We look at example 2 on the next page. Example 2 on page 249. We're going to do this one together. Write it down first. Alright, solve the equation sine theta plus 20 equals cos of theta. If theta is an element of negative 180 to 90. Okay. So what do you notice here? Again we have a sine and a cos. Can we divide both sides by cos of theta to get that? No. Why? The angles are not the same. Now you can do this when the angles are the same. Okay. Divide both sides by cos to get the tan. So what do? We keep the first one and we change the second one. If you want to change the first one, keep the second one, it's totally up to you. Okay? I will always keep the first one and change the second one. I know how to mark it if you go the other way around. Okay? So you go sine theta plus 20 is equal to. So what we're going to do about the cos? Cos can be written as sine 90 minus or theta. Why did I do that? I can have signs on either side of the equal sign. You will agree with that? So what can I do? I can drop the signs, not so. So my reference, theta plus 20 is equal to 90 minus theta. So what's the question you ask yourself at this point? What's the question we should be asking ourselves at this point? In which quadrant? Sine? Negative. Why negative? We're going to ask ourselves in which quadrant is sine? Positive. We know sine is a plus here. So which quadrant is sine positive? 1 and 2. So draw the branches quickly. Alright, so let's go with quadrant 1. What do you write for quadrant 1? Theta plus 20 equals 90 minus theta plus chi times 360. Solve for theta, we take it. So we get 2 theta is equal to 90 minus 20, which is 70. That's chi times 360. I divide by 2. I get 35 plus chi times 180. Quadrant 2. Now to get in quadrant 2. Theta plus 20 plus, now to get quadrant 2, 180 minus. So theta plus 20 equals 180 minus 90 minus theta plus chi times 360. Okay? So theta plus 20 equals 180 minus 90 plus theta plus chi times 360. If I take that over the equal sign, remember we're solving for theta. Theta minus theta will be 0. Equals 180 minus 90 is 90. Minus 20 is 70. Plus k times 360. If we work out an equation and we solve for x, so we got 0x is equal to 6, or 0 is equal to 6. What do we write for this here? If a number is equal to 0, or a number is equal to a number. No, 0 is equal to 6. What do we write if this is the case? No solution, not so. But no value for x will balance this equation here. If you got 0 is equal to 0, 5 is equal to 5, then what do we write? All true values of x exist. Not so. But if a number is equal to a different number, then we write no solution. There's no solution on this branch, but there's a solution on this branch, of course. Not so. So what do I say? And I write, to bring this into play, theta is from, remember, that k is an element of integers, no? So if I start listing, what do I say? Theta is an element of. Where do I start? I start with k is 0. If I put 0 through here, what do I get? 35 degrees. Now I put 1 where I say k. So 35 plus 1 times 180 is going to give you 215, which is outside. Not so. Then what do? I then put in negative 1. Not so. I put negative 1 in, I get 100 and, so check if that's correct. I'm going to put minus 2 in, it's going to be outside. That's where we stop. Okay. Any confusion? Alright, so let's choose one to do out of exercise 2.12. 7.12, yeah. Which one do you want me to do? Or which one are we going to do together? 6, alright, we're doing number 6. It's on page 241. Right, there's number 6. I'll give you a minute to sort yourselves out first. We'll try the sum first, and then we'll take it from there, okay? So try quickly. Right, so where do we start? We start by? Where do we start? Changing cos to sine. How do I do that? Say sine 2x minus 10 is equal to sine 90 minus x plus 14. What's up? Did I do that earlier? You didn't need to put it in a bracket. No? Now what? Let's simplify inside the bracket. So it will be sine 2x minus 10 is equal to sine 90 minus x minus 40, which is 50 minus x. So what do I do now? Drop the signs, yes? What do I write now? Reference angle is 2x minus 10 is equal to 50 minus x. What comes to mind? What question comes to mind? Which quadrant? Beside? Positive. So do that quickly. Right, so we said that sine is positive in 1 and 2. That's all. So let's go with quadrant 2. Let's go, sorry, quadrant 1. We're going to have 2x minus 10 is equal to 50 minus x plus k times 360. You would agree with that? So x is one side, numbers are the other side. So that's going to give us 3x is equal to 60 plus k times 360. So I divide by 3. So it's 20 plus k times 120. Oh, quadrant 2. How do we get in quadrant 2? 2x minus 10 equals 180 minus 50 minus x plus k times 360. So that becomes 2x minus 10 is equal to 180 minus 50 plus x plus k times 360. X is one side, numbers are the other side. So 2x minus 10, 2x minus x is x. 10 minus 50 is 130 plus 10. So 140 plus k times 360. Where k is an element of integer. You guys got that? Any confusion around this part of the calculation? Okay, did you guys work out the angles already? Yes? Okay. So we got told that x is an element of negative 180 to 180. So where do we start? Start with the first branch. So x is an element of, put 0 through wherever we see a k. be 20 degrees. Then I say K is 1. If K is 1, then this will be 140. If K is 2, it's going to be 260, which is outside the given domain. Not so? Now I put minus 1 in. 20 plus negative 1 times 120 is negative 100, which is inside that given domain. So we're going to put negative 2 in, I'm going to get negative 220, which is outside again. Can you see that, people? It must be within these stipulated values that range for the domain is. If we go here, where we see a K, we put a 0. The next branch. So I get 140. Is that correct? So that's a repeated solution. So I don't need to write it. Not so? I feel like we made a mistake here, but okay. We'll check now. If I put minus 1 in, it's going to be definitely outside. Not so? Put negative 1 in. Put negative 1 in. Also outside. Let's check if is that the only 2 solutions we have. 3 solutions. Check if that's correct. It is. Okay. Okay. So weird feeling it wasn't wrong, but okay. My feelings could be wrong. And it was. How much time we have left? 10 minutes. Right, choose another one. 3. Right, we're going with 3. 3 is a nice one. Then again, I know all sums are nice. So we're going to look at number 3. Okay, so I'll give you a chance to do it quickly. So let's do the first steps. So what do we do first? We're going to change sign to what? Cos. So it becomes cos 90 minus. So what do I do now? We can drop the causes. So what do we have? Reference 3x minus 70 is equal to 90 minus. The question comes to mind at this point. Is quadrant is cos positive. Which quadrant is cos positive? First and fourth. Okay, so do that quickly. Right, you guys sorted? Right, so what do we say now? For quadrant 1? For quadrant 1, it's simply going to be 3x minus 70 equals 90 minus x plus k times 360 all. Okay? We solve for x, we take that over. So we've got 3x plus x is 4x is equal to 90 plus 17 is 160 plus k times 360. Divided by 4, so I got 40 plus k times 90 degrees. You all got that?
Yes.
Let's go with quadrant 4. How do you get quadrant 4? 360 minus 90 minus x plus k times 360. So that gives us 3x minus 70 equals 360 minus 90 plus x plus k times 360. 3x minus x is 2x. 360 minus 90 is 270. 270 plus 70 is 340. Plus k times 360. Now, for k is an element of integers. Do we stop there? No, we would only stop there if the question was for general solution. Not so. So what do we do now? Go with the restricted domain there. Okay? So I say x is an element of. Well, divide by 2 still. No? Sorry about that. So x is equal to 1. 7 plus k times 1. Right, so let's go with it. Put 0 in the first branch, you get 40 out. Put 1 in that branch, I get 130, which is also inside. 2, definitely outside. Put minus 1, negative 50. Minus 2, outside. Not so. Put 0 in here, 170. 2 in, outside. Put negative 1 in, negative 10. Negative 2, outside. Right? Will you guys understand? Alright. So for homework, I want you guys to do the balance of exercise 5.12. Okay. 7.12. I'm not going to give you more work from here because I know you guys are writing tomorrow. Okay? So this is where we'll stop with our lesson today. Was it back up now? Why back?